Good afternoon, and thank you for coming today to this workshop on business intelligence. My name is Eddie Borges Rey, and I'm an associate professor at Northwestern University in Qatar. For the last 10 years or so, I have done research on data, automation, and similar technologies as applied to media industries and creative industries overall. But more recently, I have been working on how these technologies are applied to managerial decision making, especially in the field or in the area of media industries. So thank you for waiting until thus far. We're just waiting for more people to join us. If you allow me, I will just share my screen where I have prepared a presentation for you today. And that's us. So today we're going to be talking about business intelligence in general terms. I think I need to start with a disclaimer. This is not by any means an advanced workshop on business analytics or business intelligence. This is a bit of an overview for those of you who are considering starting to use these sort of technologies as assistants for managerial decision making. As I will make the case, you will see that the use, knowledgeable use of data will generate fantastic, remarkable insight that you can just capitalize on at moments of setting the strategies for your companies, but at the same time gaining a wider understanding of who your audience, your users, your consumers are, and what are their needs. So you have some of my contact details there if you want to follow my work. So thus far, we have heard quite a lot about this phenomenon called big data, okay? And one of the things that big data has meant so far is precisely in the corporate world, has meant potential for tapping into information, okay? That information can definitely generate revenues and other kind of benefits to the corporate world. But at the same time, we are starting to see how this phenomenon of big data was rather abstract for most of us, okay? So, it seemed that when people were talking about big data, it was this thing that was very important, that, a lot of people were saying that was the next, it was the phenomenon that will define our, the next decade. And that buzz has, to some extent, gone away just a bit, okay? We start to see people becoming quite wary of big data. What happens with, the data that I generate every day, or what happens with the data that we generate with our companies, how it's been used. And interestingly, we start to see how more and more the idea of big data was starting to be applied to, quite strange places, such as, for instance, in sports, which has been one of the areas that has capitalized more strongly in the use of data and analytics for performance improvement. But also we have seen how this has affected healthcare and how has improved the efficiency of management of patient data and things such as those. So why are we so concerned with data? Why is data so important? Why so many have regarded big data as the new oil? So imagine, the impact of, starting to shift from, oil and, petroleum as the main source of income in countries to information. And we have seen quite exponential growth in the amount of information that is generated. Perhaps we are not fully aware of how this information is generated, but what happens is with the introduction of the internet, initially, as we human beings started to interact more and more within the online environment, each one of those interactions will generate a digital footprint, will generate data. And a number of companies understood that data will generate valuable insight in terms of profiling the personalities of users, so that then they can target advertisement, quite personalized advertisement for them. Okay. So we have seen that from 2010 to 2020, we have seen that half of the data that we possess in the world has been generated in a decade. So, in the past, a large chunk of that data was enterprise data, was data that was held in companies, and that had to do with purchases, had to do with customer interactions, had to do with customer cards and all of those kind of things. But as we started to introduce certain technologies such as social media or VoIP, which is voice communication through the web, and more recently sensors in what is called this phenomenon of the smart cities, we're starting to see that more and more these technologies are capturing our interactions, our everyday behaviors, and translating those into quantifiable information. Now, we obviously will see how this growth accelerates as we introduce more and more of those technologies in our everyday lives, in our houses. The big problem that we had so far was storage of that information, and the storage of the information once cluster computing and once cloud computing were introduced, started to kind of present less and less a challenge and more a solved issue. So it's expected that by 2020, the digital universe was going to be 40 zettabytes, which is just huge. And if we take just one example of how much data is created on internet each day, you think of Facebook, for instance, there are an excess of 500 terabytes of data each day, and 3 million posts per minute. And we're talking about Facebook being one of the less popular social media if you compare it to YouTube or Instagram, for instance. But if you look at Google, for instance, there are 4 million searches per minute. So the amount of interactions is huge. Up until recently, the rate of penetration of internet in the world was not close to half. And now we can see that half of the world population have access to internet. So the market is only set to expand, offering more and more opportunities and possibilities for people interested in exploring this. Now, what happens with data when you think of data as information, and you can think of the data that perhaps you generate internally in your companies, and that has to do with for instance, purchase or customer interactions, or it could be other areas. As companies store more data, they can climb this sort of pyramid that I have put here, and gain greater understanding of how these interactions occur. So at the bottom of this pyramid, you will see there's only data. So when we have data and there are discrete elements, facts, symbols, signals, they are just basically just numbers put into a data set. They are of no use until they are put in a usable format. Okay, so one of the first challenges when it comes to managing data internally in your company is to clean that data and put it in a usable format. And data scientists for a long time have expressed that the most complex part of the world is to put data into a usable format. Once that it is put in a usable format, let's say in a database, you can start understanding relations. Who, what, when, where. You can start looking into the data to find out all of these elements. If you advance a little bit further, you can really gain knowledge by understanding the patterns. And this is basically what happens. Normally, we human beings have completely exhausted our capacity to abstractly understand large scale information. Okay, so we are only able to perhaps look at numbers drawn in or put in a formula on a sheet in front of us, but understanding numbers and information at scale, that for instance, when you think of a Excel spreadsheet of 1,000 rows, we are unable to fully see the trends and the changes, the percentage changes or the evolution in time, or all of those trends. So normally what happens is that we require certain technologies to assist us into understanding large amounts of data. And ultimately that becomes and generates wisdom. So when you understand the potential and the power that data has to lend you, further understanding, knowledge, and wisdom ultimately, that's when strategically you can start thinking about how to look at the future. So when I talk about data, for those of you who are perhaps here because you want to learn a little bit more about this could be a data set. This is a data set with just a number of columns and rows. Information can be either numbers, it could be also text, and depending of that information, we can really isolate certain columns. We can visualize in a chart certain columns, certain rows, and understand what are the parameters, what are the differences, where are the outliers, the abnormalities, what are the out of trend phenomenon, if that's what we want, or we want to see how the trend evolves and how purchases or how sales are climbing up or are dipping down. So apologies. So when we think of something as small as this data set, you might perhaps look that there are high numbers when it comes to the major lithology of other coral, which it goes or 9, for instance, when it comes to microviolet. So you are able to identify here where are the big numbers, and perhaps you don't need to visualize this. But when you're thinking about a non-SQL database like this one, is a type of database that only database platform can really handle and understand. And the way you search within the database is by launching queries in a search query bar. So when it's non-structured like this, it is really difficult to see the trends and the patterns. For that reason, then we need something like this. And this is one of the main tools that are used in the world of business intelligence. Probably you have heard quite a lot about dashboards. And this is an executive reporting dashboard. This is basically what happens is that data has been put in a visualized manner and that's a constant feed of data. So data is constantly coming through the system so that you are able to see in real time how this data is changing. Many managers on regular basis will have a computer with this dashboard ready so that they can see the fluctuations of the behavior of the markets or expectations, and how the product is being sold or bought, and the financials of the company, user experience, you name it. And this gives you a rather granular, but at the same time quite complete view of how the business is going. Okay. So imagine you have this at your reach, and you understand how to use it. You understand how these parameters work and what is good and what is bad. This gives you, quite a lot of understanding into, how to set strategies for the future, how to tackle crisis. So normally, and depending on where you work and where your area of employment is, government, for instance, government institutions, they generate a lot of data in the form of census, statistics, planning, decision making, geographical. If you are perhaps working in marketing and you're interested in exploring and understanding, consumers and users, social media can give you a lot of interesting data when it comes to geolocation, likes, shares, personal navigation. In companies, investment, staff, salaries, performance, planning, meetings, all of those elements can generate enough data so that you can have a look and understand the patterns and behaviors. So one element that is important to understand is that normally when we are thinking of big data or data in the corporate world, we're thinking of data as the raw materials to be processed in order to obtain insights, okay? In order to understand specific behavior in our consumers, to understand a specific behavior within our employees, and all of that. But at the same time, if you are able to access, the tip of the pyramid, as I saw, if you have an understanding that allows you to see beyond the patterns in the data, you can understand that data is also, or shed slide into the social technical, can work as a social technical information on the institutions and individuals that generate the data in the first place. So by looking at your data, potential competitors could understand better the ways in which you think with your setting strategies. They can understand your particular, brand philosophy or company philosophy. They can understand far beyond that just performance or results. They can understand how your company is shaped, because data can show that as well. Data, by looking at different data sets combined, by fusing data sets, you can really get a complete picture of how a person behaves or how a company works. Okay, so that is something that you have to keep in mind. So what is business intelligence and assisted decision making? So business intelligence encompasses a collection of computer technologies that support managerial work, essentially decision making. Okay, so when you think of business intelligence, there are two potential areas, three, and I will be talking about that. There's one set that helps you to understand what exists. Is the data that is generated that helps you to understand as a decision maker within your company what is happening at the moment in your company. And that's, it's basically simply analyzing the data that's being generated real time, okay? So by analyzing the data that's being generated real time, you can understand, who's purchasing what, licitations, you're understanding, how divisions and services work, the interactions. You can understand if a specific strategy has had the effects or the impacts that you were expecting and things like that. There's another dimension that has to do with predictive modeling. And predictive modeling is based in predictive statistics. It's just using a model to predict what is likely to happen in the future. And that can help you to set a strategy for the future, okay? We will be talking about those dimensions later. So these technologies have had a profound impact on corporate strategy, performance, and competitiveness, okay? And if you think, there are broadly two fields: analytics and decision support systems, okay? So when you think about how decision-making is done in nowadays, there's business environmental factors that you always need to take into account. Globalization, one of them, customer demand, government regulations, market conditions, competition, etc. And those both generate pressures and opportunities. And there's always an organizational response. So those are basically, that's the environment and the way in which companies react to those pressures and opportunities is by setting strategy or arranging for partners, collaborations, real-time response, agility, increased productivity, new vendors, new business models, etc. Now, the interesting part is, how do you set all of those? How do you decide what is a strategy to implement or to adopt, or how to become more agile, or how to think about new vendors or new business models? How do you make those decisions? And once you make those decisions, how do you implement those? There are multiple variables to consider when implementing a new business model, risk being probably the most prolific one, but you can create so many business models. So that's where business analytics comes very, very handy, because it can generate analysis, predictions, and decisions. So there's business intelligence on the one hand, and there's integrated computerized decision support on the other. So thus far, the decision-making process has been defining a problem, construct a model that describes the real world problem. We basically start thinking about, what that model, how that real world problem works, and we understand it, and we put it into pieces, into different. I start thinking about possible solutions to the model problem and evaluation of those solutions. And then we compare, choose, and recommend a potential solution to the problem. Really simple steps, and that's what in management, that's the way in which we tackle decision problems. But with information systems to support the decision making, things change, because computer applications have moved from transaction processing and monitoring activities through problem analysis and solution applications. So what we can see is that in the past, those computer applications were pretty much there for processing of transactions. You get there, you have someone entering the data, and that's it. A transaction is done in store for the sake of having bookkeeping and all of those kind of things, and being compliant with regulators. And at the same time, monitoring activities to make sure that things were happening accordingly. But now the sophistication of the technologies allows for enable problem analysis. Now assisted technologies can really provide you with a number of solutions. Potentially, when you start thinking about the applications of cutting edge technologies and business intelligence. Much of the activity, it is interestingly done with web-based technologies, and in many cases at your reach using a mobile phone. So the sophistication is not just in terms of complexity, but it's also in terms of reducing the size of the operation and the simplicity of the interface. So what you have is analytics and BI tools such as data warehousing, data mining, online analytical processing, dashboards, the use of the web for decision support. And now those are basically the cornerstones. So when you think of companies nowadays, companies that are relatively large in size, they will establish a centralized data warehouse. Okay, so if you think of companies, when we're thinking about globalization as one of the environmental issues, probably multinational corporations now are operating in different parts of the world, depending on the specific division or unit you're thinking about. So for instance, they might have a manufacturing center in any part of Southeast Asia, whilst perhaps they might have the fiscal component or unit of the company in Ireland, or anywhere where they pay low taxes. So when you think of how then you store data of all that company that is spread around the world, the response is cloud-based data warehousing, where everyone has access to the data centrally, and they can in real time have generation of insight for them to make decisions. They have quite at their reach, they have quite advanced data mining techniques, and then predictive modeling used to help them in decision making. Okay. So some of the improvements you can see and the benefits that you can see by implementing business intelligence is that enhanced group communication and collaboration. Everyone is kind of on the same page. Okay, when we are thinking, if you have invested not only in different infrastructures, but also you have invested in training and building capacity within your staff, everyone will be talking about data in the same kind of field. So everyone will be able to understand how the data is generated inside, and they can basically have an informed discussion and conversation about that. Also improve data management. Data management is one of the big aspects of having good quality data to work with on your company. Okay. Because if you don't have good quality data, then decisions can be based on flawed data, which is a problem. So managing giant data warehouses and big data is one of the big elements. And in this case, if you are not fluent in computing science or data science, I would advise you to perhaps work with a team of computing scientists or data scientists or developers or the IT department to create or to build infrastructure for this. Analytical support has improved vastly, because now we have a dispassionate computer just helping us to figure out what are the potential outcomes. We have overcome cognitive limits in processing and storing information, which was pretty much what I was saying at the beginning of this conversation. When I said that, we have certain cognitive limits, we cannot really fully grasp a 2 million row data set. We cannot really see, we could spend, days scrolling down to get to the bottom of this spreadsheet. So we have assistive technologies that help us with that. There's a massive improvement in knowledge management as well. As I said, everyone, enhances their understanding of how the company works and the philosophy of the company and everything related to that. And there's anywhere, anytime support. There's a distributed support that is allocated throughout. It's no longer, it doesn't need to be fit into a geographic space or physical space. It actually works based on the same idea of cloud computing systems. So we can see that there are, in these some sort of stairs, there are different levels when it comes to the use of analytics. The first part is reporting, which has to do with visualization, periodic ad hoc reporting, trends analysis, which is what we do when we use a dashboard, for instance. Sorry. So when we use a dashboard, most people use a dashboard for reporting purposes. You have a lot of data there. You can see fluctuations, and you can make notes of those fluctuations. You can see trends that are beneficial to the company and make notes of those. And then you can use that data and those visualizations to report to your managers, okay, to your line manager. And that's some sort of more instrumental dimension of analytics. There's also the predictive facet of this, which allows for statistical analysis and data mining and helps to set strategy, okay? So prediction is looking ahead at the future, is starting to think of, well, many companies actually pay good money to what is called futurists, which are people who are normally trying to analyze the media environment, or the the financial environment, the social, the political, to then report to these companies what is likely to happen or how the environment is likely to look like in the next 5 years for them to start setting the strategy. Futurists become somehow irrelevant because these technologies, predictive analytics and predictive frameworks, are becoming really efficient in kind of helping understand managers what's likely to happen in the future, so that they can set the strategy far in advance. And then the prescriptive facet that has to do with the management of science and models and solutions, and it has to do with start thinking about problems and how to solve them. So there are 5 guidelines to develop an analytical model that you need to take into account. So, and this is mainly going to be done by your IT unit or your computing scientist or data scientist if you have such resources in your companies, but also really involves you as end users within your services. So the first thing is developing a prototype of a model, okay? When you think about the prototype of a model, you have to think that this is a work in progress model. That the second guideline refers to the need to build insight and not black boxes. Even if users have not the advanced user level to understand how this model works inside, it is always good to make the design of the analytical model as transparent as possible, so that if someone comes new and have a bit of an understanding, they can see what is being done and how this model works. The third guideline has to do with removing unneeded complexity before handing off the model. Okay, and remember, models should be easy to use, should have an interface that is accessible and understandable and easy to navigate, because not everyone, and to be honest, most of the end users are not equipped with the knowledge and skill sets to use complex models. It is important that at the moment of developing this, there's a constant partnering and collaborations with users in the discovery and the design, so that the users can input and can decide, I don't understand how this works. Okay, so we need to make it easier. What is this? How does this work? Is it not better if you design it this way? So co-production and co-creation and co-design are essential at this stage. And you always will have a more inclined, a more someone who is more prone to use these kind of things. So that kind of person, that kind of people can be fantastic as operations research champions. And you will always have within a unit someone who can represent, can actually just help people navigate the complexity of this, or help people to change their mindset when it comes to using these models. So taking into account these some sort of elements. I wanted to discuss with you a case study, and this is the Huffington Post and how they use data, how their teams use data in their decision-making process. The Huffington Post, for those of you who don't know, is an online news. It was a news organization. Now it's a bit of a more information, entertainment, but they really kind of embrace the business intelligence technologies, and they gain a lot of insight to the point that they position themselves as one of the leading online news organizations in the United States, competing with traditional news outlets like New York Times. So how do you, out of nowhere, become a company who AOL actually acquired and paid loads of money for? Is using insight like this. So for the editorial part, the content is optimized in line with audience traffic patterns. So they already have a quite good understanding of what is it that is effective in the eyes of the audience, and use that insight to transform the editorial decision making. Also, in the development of product and technologies, the site features and product updates are made upon analyzing audience behavior, and this is all done through analytics. And then business, they also have the business dimension, revenue streams optimized based on robust product level and audience analysis. So you can see that all the way from helping you to consider audience or consumer demands, to implementation, development, or design or launch of products and technologies, business strategy, all the way to even the content of your website can be optimized using analytics. So they say that they use both big and small data. For instance, big data, large amounts of data, is used in real-time dashboards to understand social trends and recommendations as well in their news stories. What news stories should be recommended based on the personalization and moderation of the users. But small data as well, when it comes to reporting, when it comes to search engine optimization, content efficiency, consumer research, and all of that, because that gives you a more granular perspective. It actually goes to the user level, and it helps you to understand users to a quite detailed level. So they use data for content optimization, common authentication, native model efficacy, advertising regulations, passive personalization. So you can see that when you are using data in your interaction with your users, you have all these some sort of technologies that you can see here: Yahoo behavior, you can see print, deliver, mobile site, all of those kind of technologies, and that path that you can see there goes from quite wide interactions all the way to converting your audience to your product or to your service. So it starts by targeting them and build awareness on your service and product. And then as you keep engaging with them, it creates engagement. You nurture leads, a number of people that might perhaps advocate for your brand or your service. And then you convert. You actually provide them with motivation for acquiring your services or products. So this works for, so business intelligence ultimately works two ways, internally and externally. When it comes externally, in your interaction with your consumers and your brand management, customer behavior is key. So you need to look at the attitudes, the drivers of behaviors, the transactions, and the profit. Okay, so basically, when it comes to behaviors, customer behavioral data is key in unlocking breakthrough value. So when you're able to understand your clients or your users or your customers, that granularly gives you actionable research, giving you actionable insight to make decisions in terms of investment, in terms of product design. So we have seen this used by retailers like Tesco and Kroger. So for instance, Tesco uses fidelization cards as ways of gathering a lot of data from the users, as well as the e-commerce data that they gather in pretty much the same vein as Amazon. That insight helps them to even reconfigure the supermarkets, what alleys, where to position certain products, and things such as those. The thing about big data is that it allows for a 360 view on your user to a very granular level. So you can see their motivations, you can see their behaviors, what influences these people. And obviously this comes with a call for working on using this data ethically. Because we have seen after the debacle of Cambridge Analytica how this granular data has been used in an indiscriminate manner and unethically. So you can really see, you can really profile your user to a level of granularity that allows you to target your products quite specifically, and that actually serves their needs. When I think about all the advertisement that I receive on social media or on internet, most of that is perhaps things that I'm not interested in. So that means that the data is not being used properly. So when you use the data properly and you understand your user and your consumer to a good degree, you can serve them better and provide them with a service and a product that they really want to consume and they want to acquire. So you can see what they buy, you can see what they see and hear. You can see who they know and how they influence each other. You can see how they decide. You can understand their needs and their preferences, what they like. You can understand who they are. You can understand where they are and how they shop and what they buy. So all of those elements combined give you a quite clear understanding of who your audience or your user or your consumers are. But also internally helps you to generate an aligned vision across the organization. Because you obviously gathering data generates better brands and communications. It provides measurement for program design, for digital integration, for staff management, all of those things. One aspect that to me is essential here is the aspect of governance. Okay, and I will be talking a little bit more about how to align those things. When you think about how to implement this internally, yes, you can invest quite a lot of money in creating and building infrastructure, data warehouses and the tools for data mining, data reporting, dashboards. You can create all of that. But if your users are unable to understand how to use those technologies, and more importantly, how to reach that some sort of peak in the pyramid to generate, to understand data for wisdom, for obtaining wisdom, you really need to enhance two things. One is data literacy within your organization, and the other one is data governance. So the first thing is data literacy. Data literacy could refer to the abstract understanding of data as social construct, to understand the role of data in mediating our relationships to one another and to the world around us. So data literacy, and you will see, has basically two dimensions. There are people that are quite fluent in numeracy or statistic in literacy or information literacy. They know they're really fantastic in maths, and that gives you a bit of an advantage. But also data literacy is understanding that data is mediating our everyday interactions, and the ways in which those mediations are done to some extent change our behavior. So when you understand within your organization how data works in the relationship between services or between employees, and then how the brand organization is understood externally, and at the same time, how the external indicators and factors shape our company, data can give you all that insight as well. So there are two levels of data literacy. There's a functional data literacy, which responds to your ability to understand numbers. And I will talk a little bit more about that. But also, and more importantly to me, there's a critical literacy. And we often think that we need to train people in numbers. We need to train people in understanding just how these numbers work and how this reporting tool can give you, a specific insight. But understanding data as a social construct, as mediator, and how pervasive data is can also give you greater insight and adaptability when the dashboard perhaps is not giving you everything that you need. So you perhaps can go yourself and know where to obtain other forms of data that can complement your reporting line, okay? So one aspect of data literacy is that we tend to think, this is a scatter plot. And this is a type of chart that, people that perhaps know about statistics will understand really well. But not the common denominator will understand that this chart must be read in terms of correlation. The correlation is measured on that line. And the closer the points are to that line that appears there, the more correlation exists. So, information literacy, data literacy, statistical literacy are difficult subjects to understand. And in particular, they relate with logic. And logic, it is not often one thing that you are taught when you're taught, statistics or data analysis. You are expected that you will eventually acquire that some sort of knowledge, but it's not something that you're taught step by step. Which is why then we need to set real clear data governance principles within our organization, okay? So that by the time, your infrastructure and your people are equipped with the competences, your infrastructure is put together and your staff is equipped with the competences for them to make use of these technologies, you need to make sure that data is gathered, processed, and put into the where they inputted and all of that, following certain certain parameters, certain principles, or certain laws, certain guidelines. So data governance is a set of principles and practices that ensure high quality through the complete life cycle of your data. Okay. Now imagine you have someone who's entering data in a wrong manner within your services. Then your dashboards are having some sort of corrupt data, and you're making decisions that are affecting the strategy of the company based on skew data. This is a huge issue. This is a huge problem. So as you build these infrastructures and as you invite your users to co-produce in the design of the models, you really need to also implement the principles that are going to govern the data. So there are practical and actionable framework to help a variety of data stakeholders across any organization identify and meet their information needs, okay? Remember, the more people having access to the data and the more people being responsible for generating and inputting the data within the system, the more probabilities that you're going to have human error. So having a clear set of steps of how to input and how to populate data sheets and databases will help considerably in the proper constitution of your objectives and goals. So businesses do not only need systems for managing data, they need a whole system of rules with processes and procedures to make sure those rules are followed consistently every working day. So certain goals for an efficient data governance framework. The first one is make consistent, confident business decision based on truthworthy data aligned with all the various purposes for the use of the data assets within their enterprise. And when you start thinking about, there's no just one single source of data, there's not just one single type of data. There are actually quite different types of data that are used. There are quite different uses of data depending on the services. So there's a point where it becomes quite complex and complicated. So each service should have specific guidelines and a centralized guidelines and rules for the management of that. Also, it is important because to meet regulatory requirements and avoid fines by documenting the lineage of the data assets and the access controls related to the data in an improper manner. Okay, so the more you can ensure for the sake of compliance to the regulators, the better. Can improve data security by establishing data ownership and related responsibilities. Each portion of data or a data kind of aisle is owned by certain services, and if there's a security issue, who is responsible for this right away and how to implement measures to solve these issues. Define and verify data distribution policies, including the roles and accountabilities of involved internal and external entities. There's also sometimes that data is not managed in-house. There's always there's outsourcing of services of companies that provide that, and within the transaction of that data from external to external or the other way around, there might be issues. So that defining those data distribution policies are essential. You can use data to increase profits. So data monetization starts with having data that is stored, maintained, classified, and made accessible in an optimal way. Imagine Facebook or Google had issues of data governance, and when your asset is data, really, when the way your business model is monetizing data. So for those cases, that's when you really need to have a system of classifications, maintenance, and storage that are pristine. Okay. Assign data quality responsibilities in order to measure and follow up on data quality KPIs, for instance, related to the general performance and KPIs within the enterprise, okay? Plan better by not having to cleanse and structure data for each planning purposes, and that's essential. I told you that if from day one, your entry data protocols are the right ones, your data will be always be fantastic. There's not going to be need for cleaning and restructuring data. The data can basically be repurposed without having that quite laborious stage of the process. Eliminate rework by having data assets that are trusted, standardized, and capable of serving multiple purposes, pretty much what I just said. Optimize the staff effectiveness by providing data assets that meet the desired data quality threshold, not making the wrong decision based on the wrong data. Acknowledge gains and build on forward momentum in order to structure and secure stakeholder continuous commitment and a broad organizational support. Imagine, you're trying to implement this, and there are a group of people who don't feel really keen to learn data science or to know anything about data. They just want to do things the old school. So if they are already skeptical and you're implementing this because you know that this is going to help your company organization, you really want this to work properly. So data governance will allow you to implement measurements that are going to guarantee the quality of the data, because the first day that everything fails because of an issue of data governance, the first critical ones are going to be the skeptics. So make sure that when you implement your models and your frameworks, everything is working fantastically. And with this, I conclude my presentation today. I would love to open the floor for further questions. You can use the question and answer functionality to ask me questions, and that's pretty much it. Thank you very much. I believe so. If you want me to share those, I will be more than happy. I will give this to the organization of the event so that they can distribute it accordingly. Question here: what would you advise a person who would like to get into big data? Well, that is a fantastic question, because it feels with the it is not from 2010 we started to hear about big data, and although we don't hear much about big data anymore, technologies such as Internet of Things or artificial intelligence are incredibly dependent on data science. So if you are keen to do that, there are ways for you to get into different streams of data science. It will depend on whether you want data science for business purposes or whether you want data science for computing science purposes. There are a number of courses, masters, training, education, courses online that train you for this. I would say that the first thing, if you are not a person that is fluent in numeracy or statistics, all of that, I will ask you to start perhaps building your foundation of mathematics. Okay, considering I'm not very savvy regarding maths, computing science, and how important that is. Okay, so I would say that's the first step. Just try perhaps to find a course on statistics or attending. There are many online platforms that offer statistics. There are many good training facilities completely for free that help you to do kind of elementary on data science. I'm a former journalist, and I worked as a journalist for 15 years, a media producer. And then I became academic and I started to do research on big data. And I decided to do a master's on data science. But I encountered it really difficult at the beginning because, these are courses that are assuming that you understand maths or general maths, what they call general maths, which for me were matrices and, really abstract and complicated things. So I would say that perhaps start building your foundation of maths and statistics, and that will lead you to natural progression into programming, and then into natural progression to understanding, data science at large. There you go. So you're pretty much like me. Yes. So if you did exactly like I did during my bachelor's degree, I did like 3 courses on statistics, because as a journalist, you need to understand statistics for reporting purposes. But the understanding of statistics that you require for being able to build a predictive model is far advanced. So I would advise you to go online, Coursera. Even if you want to go to courses by Stanford University, they have good foundational courses on data science and statistics. So perhaps doing one of those can help you to gain a greater understanding, and then you can diversify yourself based on what type of data science you want to pursue, whether more business oriented or whether more developing tools oriented. Okay, my absolute pleasure. Thank you very much for coming. Have a good night.